Hey, we're back on another problem. Let F be a finite field of odd characteristic. Prove that the rings f adjoint x mod x squared minus alpha, or the ideal generated by x squared minus alpha, as alpha ranges over all non-zero elements of F fall into exactly two isomorphism classes. Okay. Do you have an idea of how to do this problem? You just think about it for a minute. I'll give you some time. Because odd doesn't mean prime. I don't even know. I mean, we could pick prime odd and do that to look at it, but odd doesn't mean prime. So think of a prime composite. I mean, think of an odd composite one. And what are the isomorphism classes? You know? Okay. There are two possibilities. Yep. That's why we have these isomorphism classes. That's why I thought. D is a square. I put D just because I don't feel like writing alpha. Okay. We could put square free. I just say square free because that's what people say. Okay. Okay. Splits into linear factors over F. That's, you know. Oh, da 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 da. Characteristic is odd. Okay, that's the first isomorphism class, right? Like, Like, obviously. No offense if this isn't obvious to you. I'm not saying for you it needs to be obvious. It's obvious to me once I write the solution down. Like, it's like it could only go, there's only one or two ways it could go, right? Let's see. If D Okay, let's go over it real quick. This is probably one of the fastest ones I did. Let F be a finite field of odd characteristic. Prove that the rings F adjoint X mod the ideal generated by X squared minus D as D ranges over all non-zero elements of F fall into exactly two isomorphism classes. Either the polynomial is irreducible or it's not. If it's irreducible, we're going to get the second case, which is going to give us a field extension that pretty much looks like that's a quadratic extension. Just how, like, in ring theory, C is a quadratic extension of R using I as a square-free irrational number. And then the second case, which is the first case, is that it does split, and then we get these linear factors. And then those would be irreducibles, and then we can just take the direct product of those. So we're either going to have F times F, or we're going to have F squared. Or we're going to have F adjoin D. Not the same thing, right? And there you go.